Hello friends, this is Clayton Fernando. In today's section, we are going to see a brief review about the chromatography and its types, and then how the chromatography can be used for the separation of compounds like that things in research and industrial purposes. We are going to see. First of all, what is why we need to go for chromatography means generally the biosuppression process or any process we can classify into upstream and downstream process. In upstream process, the products they are produced from the inoculated material, and then in downstream process the products are separated from the impurities. So we can separate the downstream process into two categories. In the first category, they are removing the impurities by some of the process like precipitation, coagulation, adsorption, like that process. So in that process what happens is they are removing they are removing the impurities, which makes the product as concentrated. So after the second process of downstream process, it makes the product as purified form. So it may lead to to be diluted in form also. So some of the methods for purification of compounds like dialysis, extraction, and chromatography, like that process. One of the majorly used and well accurate method is chromatography. So what is chromatography? Chromatography is a physical method for separation of compound which was developed by Twist. He made a glass column made filled with calcium carbonate, which separates chlorophyll and xanthophyll. So here they are using two types of ca- two types of liquids like stationary phase. This is nothing but absorbent. Another one is mobile phase. The stationary phase may be a solid or liquid. If liquid is used means it is supported on the solid. So under the mobile phase is liquid or gas. So some of the technical terms used in chromatography are analyte, which is nothing but the sample or solute we are we are used to separate. And then the eluate, which is nothing but the mobile phase solvent, which makes the our solute to pass through the stationary phase. And eluate is the mobile phase that exists in the column. So there are different classifications of chromatography based on different aspects. First type of aspect is based on type of the chromatographic bed. We can classify the chromatography into planar and column chromatography. In planar chromatography there are two types. One is paper chromatography, another one is thin layer chromatography, that is TLC. So based on the stationary phase using in the planar chromatography, the two types are classified. If we use paper as a stationary phase, then it is a planar chromatography. Then silica gel or alumina as a stationary phase, it means it is plain chromatography, that is thin layer chromatography. In thin layer chromatography they are using the stationary phase of silica gel or alumina coated on the glass, metal, or plastic plate. So and then in column chromatography they are using stationary bed that is packed within the column, then based on the mechanism of separation there are different types of classification of chromatography. One is partition, adsorption, size exclusion, affinity, ionization. And then based on physical state of mobile and stationary phase, there are different types of chromatography. That side picture smart art represent the that classification. If we use mobile phases, gas means that is gas chromatography, mobile phase is liquid means that is liquid chromatography. And then stationary phase is liquid and mobile phase is gas means gas liquid chromatography. As gas liquid, gas solid, liquid solid, liquid chromatography are all classified. Then this is the general classification of chromatography representation. We can classify the overall chromatography into two types, column and planar. In planar there are two types of types assignment mentioned in earlier. One is planar and liquid. And in column chromatography there are based on mobile phase using, there are two types, gas and liquid. And based on stationary phase the below types are classified: gas solid, gas liquid, gas liquid solid, bonded phase chromatography, liquid chromatography. Then this is the mechanism of different types of chromatography, and the mechanism which used in specific techniques of chromatography are explained in this tabular column. So first type of classification, they are using mobile phase as liquid phase. Stationary phase, for stationary phase there are different types of format they are used, like solid or adsorbed liquid or organic bonded phase, ion exchange resin, and liquid in phase of organic bit. Like different forms, different types of mechanism for separation of compounds are using. So for first case they are using solid as stationary phase. In mobile phases liquid, the mechanism of separation is adsorption, and the specific technique used for chromatography is like liquid solid chromatography, thin layer chromatography, as like as the entire table are presented. In second classification, mobile phases gas, and based on stationary phase, there are two types of mechanism of separation, adsorption, partition, like that thing. Mm, then based on protein, we are going to separate based on the properties of the solute. We need to choose the chromatography that is represented in this table. Then adsorption chromatography. In adsorption chromatography means we can classify the both entire column chromatography into two types as adsorption chromatography and partition chromatography. Based on the mechanism of separation, we can classify. First one is adsorption chromatography. In adsorption chromatography, what happens is the entire mixture of compound are separated into are adsorbed into the stationary phase. Based on that, the separation happens. For example, polar stationary phase is used for separation of polar compound, because the polar compound is more attracted more towards the stationary phase, as like as non-polar stationary phase for non-polar compound separation. So the differences of non-covalent interaction towards the stationary phase makes different rate of flow towards the column. So the less tightly bonded molecule elute for earlier, and the tightly bounded molecule are eluted later. Based on that, the separation happens. So the stationary phase, here the stationary phase is solid, and the mobile phase is may be either liquid or gas. If the mobile phase is liquid, means liquid solid chromatography. If the mobile phase is gas, means gas solid chromatography. And some of the adsorbent, that is stationary phase used in adsorption chromatography is for polar acidic adsorbent is silica, polar basic adsorbent is alumina, non-polar adsorbent is charcoal. In polar adsorption, what happens is there is a formation of hydroxyl groups between the hydrogen bond of solute with stationary phase. So the hydrogen bond is established, so it leads to non-covalent bond formation. Then partition chromatography. In partition chromatography, what happens is the mixture of solutes in our sample distributed to between two phases based on its solubility. So here the stationary phase is liquid and mobile phases may be either liquid or gas. So liquid or stationary phase means it is physically absorbed or chemically bonded toward the some of the support matrix. Then in liquid chromatography, the sample, that is our solute, separated between the mobile phase and liquid phase, mobile phase and stationary phase. Then in gas solid chromatography, the solute to be distributed within the stationary phase. The distribution of molecule between the phases can be measured using the partition coefficient, that is Kd equal to concentration of solute in phase A to the concentration of solute in phase B. This diagram represents the distribution of molecule between the two phases. In the previous adsorption chromatography, the molecule which is adsorbed, that is described in this diagram. Then Then first, one of the example for partition chromatography is paper chromatography or thin layer chromatography. Here the solute is partition are distributed between the stationary phase and mobile phase substance which is more soluble, which has more favor, we can say. So favor for mobile phase the pass rapidly through the stationary phase. So substance which is more soluble in stationary phase, that is retarded, so it moves slowly. One of the best example for liquid liquid chromatography is paper chromatography. Here what we are doing is we are using solvent which contains organic and aqueous phase. Organic compound migrates towards the paper, so it forms a mobile phase. It migrate because of its nature as non-polar compound. Then aqueous containing in the solvent bind towards the bind towards the cellulose of the paper because of its polar nature, so it forms as a stationary phase. So the solvent soaks into the paper by capillary action. That is the mechanism behind in paper chromatography. Then, based on relative solubility between the stationary phase and nonpolar mobile phase, the molecule to be distributed. So, the solvent flow we can make as either is ascending or descending flow. Um, Here, the paper chromatography, no, no, sorry. Planar chromatography we can classify into two types: normal phase or reversed type. In normal phase, stationary phase is more polar than mobile phase. In reversed phase, mobile phase is more polar than stationary phase. So to elute polar solute, we can use normal planar chromatography. To elute nonpolar compounds means we can use reversed phase planar chromatography. Then advantage of using descending chromatography is it moves faster because it aids the flow by gravity, so it can be used for separation of smaller RF value compounds. Because for small RF value compounds, we need large flow. If we need for large flow, is assisted by gravity means it flows easily. This diagram represents the ascending flow. So um, the solute placed in the bottom of the paper move towards the upwards. So the migration of the molecule are described by relative front is the ratio between distance traveled by substance to the solvent front. Then size exclusion chromatography. In size exclusion chromatography, the molecules of our protein separated based on size and shape in size exclusion chromatography. In size exclusion chromatography, they are using porous gel made of insoluble hydrated polymer is used as stationary phase. Some of the stationary phase commercially available beads are polyacrylamide, destron, or agarose, and the commercial names of the stationary phases are separacil, separasets, and separose, like the thing. So in size systems chromatography we can classify into two types: gel permeation and gel filtration chromatography. In gel permeation, mobile phase is organic. In gel filtration, as mobile phase as aqueous. So larger molecules of our solute are eluted first, while the smaller molecule elute later because it enters into the bead. This diagram represents small molecule enters into the bead, so the retention time and path for the small molecule is long, so it elutes slower. So protein eluted in decreasing order of molecule size, so we need to choose the correct pore size of a bead and solvent we are using. Based on that, this molecule to be separated. We can see this diagram: the larger molecule are eluted first, and the smaller molecule are eluted last. Then this table represent based on size of our protein um, what type of support matrix, what type of insoluble hydrated polymer, that is a stationary phase we can use this table represent. Then exclusion limit is nothing but the smallest molecule even unable to penetrate the pores is called exclusion limit. So the molecule greater than the exclusion limit does not enter in the pore. The distribution coefficient for the pore are represented by kd is equal to 0 mean it excluded by the pores. Then the distribution coefficient kd is equal to 1 is the mean, which means that the inner solvent of the porous bead can be accessible. So the intermediate sizes for the intermediate size of the solute which has the kd ranges from 0 to 1. So this size exclusion chromatography, this size in size exclusion chromatography we can use it to measure the size of our protein also. So how they are using size exclusion chromatography to measure the size of the our protein means, so first formula is Vt is equal to V naught plus Vi plus Vg. So V naught is nothing but the external volume of solvent available in the sorry, volume of solute available in the external packing material. Volume available in the internal pores is represented by Vi. Vg is the volume of packing material bed. So add summation of all these things we can get Vt. From this formula they are calculating Vo and Vi, and then put into the another formula V is equal to V naught plus V sigma Vi. By putting this, we know V naught Vi and Ve, which is nothing but the volume required for elute of our solute. We can from this we can calculate the sigma, that is partition coefficient of our solute. So the partition coefficient ranges from 0 to 1, and by putting the partition coefficient of noun protein versus the size of our noun protein in a standard plot, and then we can put the partition coefficient of unknown protein. By that way we can find the size of our protein as like as we calculate the unknown protein concentration using Bradford assay like that thing. So then ion exchange chromatography. In ion exchange chromatography, separate molecule based on a charged molecule. Here the stationary phase is ion exchanger. Ion exchanger is nothing but insoluble matrix covalently attached to the charged group within and on surface of the matrix. So the solute eluted by buff. So here the solute bound to the insoluble matrix containing charged group. After that the bonding can be replaced by increased can after that the bonding of solute to be eluted by increased ionic strength or by increasing pH, which leads to displacement or decreasing the strength of interaction. So the entire ion exchange chromatography we can classify into cation and anion exchange chromatography. In cation exchange chromatography, positive charged molecules are separated. In anion exchange chromatography, negative molecules are separated. This classification based on charged molecule of the in ion exchanger, and another classification based on functional group we can classify into ion exchanger in strong and weak. In strong means we can classify into acidic cation exchanger, basic anion exchanger. In basic anion exchanger mean what type of functional group are most commonly present in anion exchanger means quaternary amino group, like that classification are also here. Then the strength of interaction depends on size of the charge of solute and charge density. So here some of the commonly used ion exchanger are represented in this diagram. Then this is the structural diagram of insoluble matrix attached to the bead. So first one represent DEAE, that is which is nothing but anion exchanger. Another one is CM cellulose, that is carboxyl methyl cellulose, that is cation exchanger. Then this process represent the mature molecule are separated. So here the negative molecules are separated um, by removing of positive molecule. So how can we select the ion exchanger means most of the solute contain both positive and negative charge. So what they are doing is at the isoelectric point there is no negative charge, no charge. So either by increasing above the isoelectric point or by decreasing below the point, so the entire charged molecule on the surface of the elute are contain only one type of charged molecule. So by that way they can select the ion exchanger. So for every elute there are two methods of separation is possible. Based on the stability of our solute we can select the type of ion exchanger. This diagram represent above isoelectric point, that is there is net negative charge, it binds to anion exchanger. Below isoelectric point it leads to net positive charge, it binds to cation exchanger. Then also we don't know the isoelectric point in most of the cases. So what they are doing is small amount of solute and ion exchanger mixed in separate tubes. Different types of ion exchanger and different solute are mixed in buffer containing tube in different tubes. So after the 15 minutes of centrifugation they are checking the supernatant containing solute. If low amount of solute contained means that is the suitable ionization. By that way buffer concentration and the change of pH everything they are determining. So the so another problem is buffer choosing is if they are using anion exchanger means it leads to binding of binding towards the ca- support matrix, which may disrupt the capacity of the column. So it will be avoided by using opposite same charged molecule which is present in the support matrix that also be present in buffer will be preferred. So and also the molecular interaction will be reduced by using a reduced concentration of ions. 0.05 to 0.1 molar is recommended. This is one of the case study. What they are doing is what they are saying is they are using one of the protein which has the protein stability between 5 to 7. So what which type of chromatography ion exchanger we can use, at what pH we can use, they are asking. So they are done as like a told trial and error method. At different pHs they are interacting the our matrix with solute. So after centrifugation we can able to see at pH 6.5 the molecular interacts the ion the solutes to be interacted toward the ion exchanger. So we can use 6.5. If we use 7.5 means it leads to strong bind, so the elution makes a problem. We need large more harmful buffer. It may lead to inactive our protein, lot of problem, it may create lot of problem. Then affinity chromatography. In affinity chromatography, based on biological function and chemical structure the molecules to be separated. So here the molecule biospecific ligands are covalently attached towards the matrix. Here what are the steps mean, first we need to choose the appropriate ligand and immobilization of ligand to the matrix and binding of solute to the ligand and removal of non-specific and non-specific molecule and then elevation of our molecule of interest. This table represent based on the target of a molecule what type of ligand we can use for our chromatography separation. Then this one of the case study for separation of mRNA molecule from other molecules. What can we do means they are using oligo DT cellulose which contain short T fragment. So if we make an interaction of RNA molecule, only mRNA molecule has a polyatyl which makes a duplex formation with the DT cellulose. It lets by that way they are separating. So here what the strategy they are using is high salt concentration make the duplex which is nothing but double standard formation. So the other non-specific molecules are eluted. After that low salt buffer they are giving, it destabilizes the duplex and then the poly a tail containing mRNA to be eluted. So the choice of ligand we are used for selecting the affinity chromatography based on different criteria we can select, that is specificity, reversibility, stability, size and affinity. Affinity is measured by using equilibrium dissociation constant KD. Then the entire affinity chromatography we can classify into pseudo affinity and IMAC, that is immobilized metal affinity chromatography. In pseudo affinity, instead of normal ligand, they are using dyes as the ligand. So there are two case studies. In first case study, a study of Tulsani may used this dye as a ligand to separate three molecules at the same time, that is lactase dehydrogenase, pyruvate kinase and aldolase. So here one of the advantages this dye, if we use dye as a ligand mean it is not not a specific ligand. So large number of molecule are eluted at the same time. And in case 2, this type of chromatography also used for separation of IgG and albumin from blood components. So the IgG molecule and these things are used for diagnostic purposes. So here what type of dye they are using is mimetic blue SAA6HI dye. Here combined use of normal affinity chromatography and then pseudo affinity chromatography they are used for separation. How they are preparing for pseudo affinity dye is mentioned in this the is mentioned in. Then in immobilized affinity chromatography what they are doing is this picture we can see clearly. First ligand is bounded towards the matrix and then in ligand a metal ion is fixed. So one of the example of immobilized metal affinity chromatography is nickel affinity NINT affinity chromatography. What they are making is a ligand is bounded to the gel bead and in the ligand a Ni metal ion is fixed. So most of the time for recombinant protein they are making the recombinant protein with the histidine tagged. So the recombinant protein contain uh, histidine sequence which makes more attraction towards Ni. So by that way the histidine are bonded towards the Ni in the immobilized metal affinity chromatography, that is NINT chromatography. By that way the recombinant protein are separated in this immobilized metal affinity chromatography. In our study, so so these are some of the different types of chelating groups. Like this only I am mentioned NINT affinity chromatography, nitrotetracyclic acid. So some other types of immobilized metal affinity chromatography are mentioned in this table. Then this diagram represents how the interaction of histidine towards NINT affinity chromatography. Then in our study we also made a recombinant protein. This two band represents overexpression of our protein and then that molecules are purified using affinity chromatography, NANT affinity chromatography. So here faced a problem, that is another compound which is more which also contain histidine tagged, so that compound are also eluted. So what we done is that eluted compound we get into the size resolution chromatography, and then we get our protein as in purified form. Then DNA affinity chromatography also used for to separate DNA binding protein. So how they are eluting the DNA affinity chromatography are mentioned in this diagram. Then hydrophobic affinity chromatography. In hydrophobic affinity chromatography, they are they are eluting the hydrophobic proteins. So how they are making is they are reducing the solvation, that is the binding of solute and solvent. This diagram represent the binding of solute and solvent. So by making high salt buffer the solvation to be reduced, so the hydrophobic region that become exposed and absorbed by the media. So more hydrophobic the molecule, less salt is needed to promote binding. Usually decreasing salt gradient is used to elute sample from column in order of increasing hydrophobicity. Then HPLC chromatography, it's an extended version of liquid chromatography. Here the mobile phase is liquid and the stationary phase is solid or liquid. If stationary phase is solid mean that is adsorption chromatography, or liquid means that is partition chromatography. Instead of mobile phase driving by gravity, here high pressure we are giving, so it forms a high performance and high speed than traditional column chromatography. HPLC can be functioned in different form of chromatography in different modes. So that different modes are adsorption, partition, ionization, size exclusion. Sometimes in combined modes are also they can perform. So the efficiency of separating the molecule is mentioned in resolution. So the classical chromatography is low flow rate and particle smaller molecules are not possible to separate. And but in HPLC, due to pressure high, small molecules are separated easily, so it forms a high resolving power and short analysis time. So the entire HPLC we can classify into normal phase chromatography, reverse phase chromatography. Reverse phase chromatography is normally used. In normal phase, the stationary phase is polar, mobile phase is non-polar, and reverse phase chromatography, stationary phase is non-polar and mobile. As I mentioned in earlier, that is planar chromatography. Also, they are separating this kind of separation. Then this is the diagrammatic representation how HPLC is working. So um, so the pressure is giving as constant to for the flow of solvent through the column. So the sample to be injected at this point, and then the sample that is solute with our solvent enters into the column, that HPLC column, which is made up of stainless steel or glass Teflon tubing, based on separation of copper compound. Analytical separation or preparative compound different in diameter and different lengths are used. For length mostly 10 to 20 centimeter is preferred due to high pressure up to 400 atmosphere. It moves fast as I told you earlier, and very small particle are also separated, which makes a higher resolution, in which forms advantages of HPLC. In gas chromatography, mobile phase is carrier gas and stationary phase is solid. The stationary phase is solid means that is gas solid chromatography. Liquid or in means there is gas liquid chromatography. In gas liquid chromatography is also called as, is generally regarded as gas chromatography. Here the stationary phase liquid is inverted on support matrix. So gas chromatography is used to analyze the volatile compound, that is the compound which evaporates readily is used in gas chromatography. So in gas solid chromatography, retention of solute by physical adsorption. In gas liquid chromatography, the solute to be partitioned between mobile phase as gas and liquid phase that is immobilized on surface. So the solute to be partitioned between these two phases. Mobile phase also called as carrier gas, which need to be dry, free of oxygen and chemically inert. Some of the examples of carrier gas are helium, nitrogen, argon, hydrogen. So based on performance and the detector used, we need to choose the mobile phase. This diagram represents how the gas chromatography is working. So the gas carrier gas is pressurized in the gas cylinder, which is controlled by the regulator, gauges and flow meter, and then the sample to be injected in the injet port. The injet port column and the detector are held independent in isothermal oven at various temperature. So the solute to be heated to vaporize the sample and detector detect the eluting component. Based on that, it is processed. It is also extended version of liquid partition chromatography. Carrier gas is analogous to solute, so the molecule to be separated between mobile phase gas and solute liquid, stationary phase and liquid. Okay, thank you guys.